Welcome to the Algebra Final Review. Here's our last standard finally. Standard 11, which was on scatter plots and correlation. We want to review quickly how to make a complete graph, select the independent and dependent variables, and interpret the scatter plot. We did a lot on this, so hopefully it won't be too unfamiliar to you. Remember that when we make a complete graph, we want to make sure that we've labeled the x and y axis, the scale is consistent and correct, the data is in the correct location, and the axis is labeled with what it represents. Okay, here's some common scale errors, and we're going to use this as kind of a guide real quick. Okay, on this one, they really haven't told us much on the graph. We know that this point is probably at 2,8, but we have no idea what x represents or what y represents, and we're a little bit stuck as to really if there is a scale, much of a scale going on. Okay, it does show both axes, which is good, and would probably pass, but we really want to have a better graph. On this one, they've got our x-axis labeled here and our y-axis, and they have a scale. Now I'm going to tell you first that your scale should look like this: 5, 10, 15, 20, 25, 30. It will look like a times table going up or to the side. This graph still has a problem though. We want our times tables to start at 0. So the x-axis should always be 0 and the y-axis should always be 0. So right here should be the point 0, 0, but it's not. If I use the graph as they've shown it, the point right here would be the point 2, 5. And so remember that when you draw your x and y axis, that the x needs to start with 0, so 0, 1, 2, 3, 4, 5. 0 on the y, 1, 2, 3, 4, 5. It needs to go up and it needs to have the same spacing. There's nothing wrong with the spacing on here or even here, but it needs to start with 0 at the origin or where the two axes cross. Okay, notice that here I went up by 1. That's okay. You can go up by 5s, you can go up by 10s. Okay, here's another one. If you look at this scale, all of these are placed equal distance apart, which is good, but the distance from 8 to 17 is actually 9, and from 17 to 35 I think is 18. And then the distance from 35 to 44 would be 9 again. And so they haven't spaced. If these are truly what they're supposed to be, this would have to be like 8, this would be 16, this one would be 24, and this one would be 32. They're going up by a matter of 8, and then of course we want to label that we started at 0. Okay, this one has the same general kind of problem. The numbers, some of them are okay. They go up by 1 here, 2 here, and then 1 here. And so that's not a good scale. It should look like a times table, like 8, 16, 24, 32, or 0, 1, 2, 3, and 4. Okay, you could also have used, if you wanted to start it, actually start at 2, you could have said 2, 4, 6, and 8. But you don't want to have your numbers just random. Okay, let's look at this one and see what's happening here. Nice that they started here at 0. This would be 0, and then this would be 2. This would be 3, 4, 5, 6. So the numbers are going up very nicely here. But there's a problem right here. They're going up by 1, and so the first number should be 1. So this should be 1, 2, 3, 4, 5. This skipped too much space. Remember, we think of it almost like a ruler. If this was a ruler, then it started here at 0, and this was 2, and then this was 3, then all my units are not the same going this way. Let's check going up and see how that looks. 0, 5, 10, 15, 20, 25, 30. That looks good. Okay, remember that, you should be labeling it with something like age and toys or something like that. Now, just to kind of cover on here, when you have a graph like this, the x represents the independent variable and the y represents the dependent variable. So what you might think of that is like this. There's an example I really like. It's a chart, and it shows the number of manatees killed and, let's see, number manatees killed and the number of motorboat registrations. And what's happening is here we kind of want to think about which one is causing the other to happen. For example, does the number of manatees killed affect or control the number of people who register their vote? In other words, if 5 extra manatees got killed and suddenly there's going to be more people registering their motorboat? Or do the number of motorboat registrations affect the number of manatees killed? Well, it's logical that this would affect that. So the number of motorboat registrations is what we're keeping track of, and how many manatees are killed as a result of that. And so on a graph, this would be the number of registrations, and this would be the number of killed manatees. Remember, once again, independent and dependent. Now give us a problem. Oh, I just want to talk to you about correlation before we get actually started with the problem. Here's 2 different graphs I drew really quickly, and we want to talk about their correlations. If the data is just all spread out and I were to draw a line through it, the distance to that line, any line that I drew, would always be really far. But I can look at this data and I can kind of figure out there's a line that I could draw through it that would be kind of close to the direction the data was traveling. It's like that. And the points really aren't that far off, at least most of them aren't. And so this one would have a strong correlation because the data looks really good. Even if you have like 1 out here, it's okay. It's just most of the data is all together. In this one, it's just too spread out. I could draw that line through it, I could draw that line, I could draw that line, and I'm really not sure which direction it's going, whether it's increasing like this one over here, or whether it would be decreasing, it's kind of going down. And so this has a weak correlation. Okay, now the problem. We're supposed to plot the points, make a complete graph, do all those kind of things for the data table. I'm going to try to do that as quickly as I can. When I look at the table, I think that height is going to affect shoe length. So I'm going to make this my independent variable and this my dependent, my x and my y. So I'm going to go ahead and label that on here. This is going to be height, and this is going to be shoe length. Okay, and let's look at our numbers here. Our numbers go from about 133 to about 180. So I need a scale that'll go up to 180. And let's see how many lines I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've only got 10, so I probably better go up by 20s. So this would be 20. I'm just going to write it kind of sideways down here so we can see it. This would be 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay. That's for that. These numbers aren't as big, and so I can really start them actually at a smaller number. Looks like the biggest number is 32, so maybe if I went up by 5s on the x, so 5, 10, 15, 20, 25, 30, 35, 40. Okay, I've now got my scale in there. And remember, my scale on that one's down there. I didn't want to clutter up my graph up here as much. Okay, so the first point is at 50, 25. So 20, 40, 50 is about right here, 50, and then 25 right there. The next one's at 180, which is this line, and 32, which is right about there. 170 and 30, right about there. 133. Let's see, 133 is going to be right about here. And and it's 18. It's probably right about there. 166 and 27. 142 and 21. And 151 and 22, so right about there. So that data actually looks pretty strongly correlated, and we'll finish this in the next video.